Okay, well, welcome to our next lesson. So if you've run the code successfully to create the table and insert the data, you'll see the results below. And we've gone over all the data types and all the useful information that's in the create table statement that's good for you to know, like the primary key, the not null, the data types themselves, and then the generated always as identity. So if all those things make sense to you, they're all good to know as you look at the data in the table and make sense of it. What's nice about formatting the data this way is you don't actually need to retrieve the results of the table to look at the data while you're writing in query. So I'll continue to format the data this way, and I won't use too many rows so you can kind of look at it as you write your queries. So we're finally going to jump into writing some query SQL, which is the focus of this course after all. So let's do some of that. Before that though, I do want to show you an easier way to clear the results of your screen than I showed you last time, especially if you have code on both sides of the screen. So last time we just had code on schema SQL, so you could just copy the code, hit Control A to select everything, Control C to copy, and hit the database symbol to reset the site. But actually, if you've got code on both sides, the easiest thing to do is to just hit the update statement here, or the update button here. You'll see that'll create a new version of your code, and it clears the results below. Okay, let's write a little bit of SQL. So the first keyword you're going to learn in query SQL is select. Select is a clause of SQL, meaning it's a main structure within the SQL statement. You'll see we have numerous what are called clauses within SQL that we use to sort of segment the SQL statement in query SQL. Select is pretty much always going to be there. It's what tells the database what columns you want to see in your query results. So the easiest way to tell the database what columns you want to see is to just use a star. So if we say a star, we're saying we want to see all the columns and all the rows, especially if we don't put anything else after it. Later we could do something that could restrict the number of rows, but think of it as meaning all of the columns, the star. Okay, then we do from. From is the next clause in SQL. So from is where we tell the database what tables we want to pull the data from. In this case, we just have one table, which is users. So we're going to say users. And then we always end our SQL statements with a semicolon. So we'll put a semicolon. So this is one of the simplest queries you'll write, but very useful because you're basically saying show me all the columns, that's what the star means again, and then show me all the rows, and that's because we haven't put any other statements within the query SQL to filter out to only show some of the rows. We'll do that later. So let's run this and see what happens. You can either hit run up here or control enter on the keyboard. So now we see the results. So we have, you can see all 4 rows of the data that we inserted. You can see it pretty much matches what we have up here. We've got the names, Bob, Sylvester, Jim, Beth, ages, including the null, credit balance, date created. The one thing that's interesting here is after each date, there's a time code attached. That's just the way that Postgres formats any dates that you output, even if they don't include time. We'll cover in a future lesson how to change that format. The other thing we see that is not in the insert statement above are the IDs. And again, those are auto-generated, generated by our qualifier here, generate always as identity. And you can see they work exactly how I described them. The first row gets a 1, then 2, then 3, then 4. They're not in the insert statement here because they're inserted automatically as a result of the way the table is structured. All right. What if we only want to see one of those columns, or maybe 2? Well, we can specify the columns we want to see by typing in the names of the columns right here. So perhaps I just want to see the name, and then we'll put a comma, and then the age, and we can run it just like this. So that's easy enough to just specify some of the columns from a table. We can also rename, if we want to, the column. So if we're going to print this output out or take a screenshot, we want to give it a different name. We can certainly say name. Perhaps we know that name means first name, but we want the person reading the output to know that it's first name. And we can type as, and then whatever name we want to give it. So again, no spaces, but we can do first name and run that, and there we go. Okay, so we've got first name and then age. Okay, next we'll run the simplest SQL query that's possible to write. And that is selecting what are called literals. So we don't even need the from statement here, or the from clause in SQL. We're not going to actually pull from the table at all. The simplest SQL query you can write is just select one. Let's run that. And you can see the output is a 1. So that's called a literal. It's a literal value. It's not coming from a table. We're just typing it in. It can also be an expression. So we can say 1 plus 3, and we're going to get not 1 plus 3, but the result, 4. We can also type strings as well, meaning like character data, like name. We'll need to put that in single quotes, but then we can do it just like that and select, and you'll see the results right there. Okay, so you might wonder, why would I use this? It's not common. Sometimes you'll use it to add to a field that you already have, or maybe preface a name with a Mr. or Mrs. or Ms., depending on the gender, if you have that in your table. But normally you're not just selecting literals, but some examples that might come in handy are doing a little bit of math. So if we do 3 minus 4, I just want to show you that negative numbers are supported. So we get a -1. Something a bit more useful, if you don't have a calculator handy, you need to know what 450 times 32 is. There's your quick result, 14,400. What about a little division? Let's try 3 divided by 4. Oops, 0. Well, we know that 0 is not the answer. We know it should be 3/4, which is 0.75. Why are we getting a 0? Well, that has to do with data types. So that's why data types are so important. And when you're typing in a literal number like this, if you don't have a decimal point on a number, it assumes it's an integer data type. So we've got an integer 3 divided by an integer 4. Well, the result of an operation on 2 integers is going to be an integer, and an integer cannot have a decimal value. So what happens, and this is database dependent, the SQL standard doesn't actually specify what you need to do here, but the options are to either truncate the decimal, which is done here, hence the 0. We've essentially just chopped off the 0.75, or it could be rounded. And so it's up to the database designer to basically decide how they want to do it. The standard doesn't tell you what to do. PostgreSQL, as you can see, truncates it. So to keep that from happening, let's change one of these numbers to be a decimal data type by just typing a 0.0 after it. Now when we run it, we're going to get that 0.75 like we were hoping for. We also see this come up when we use a function like the round function. If we round 3 divided by 4.0, and we can tell this is a function because it has parentheses, and then what are called the arguments go inside the parentheses, the arguments for the function. In this case, there's only one argument, so it's this expression 3 divided by 4.0. If there were more than one, they would be separated by commas. So if we run this round statement, we're going to get rounded up to 1 like we would expect. But notice, it doesn't help to put that round on 3 divided by 4. And you might wonder why. You might wonder, well, we only you know, it's integer divided by integer, so we only want to see an integer. Why doesn't it just round it up to 1? That has to do with the order of operations. The order of operations decides how fast, or excuse me, the order that things happen in SQL. So it's important to understand that not everything in SQL happens at once. There's an order to everything SQL does. And in this case, what is inside of the function, the argument inside the function, is evaluated before the function is run. So the 3 divided by 4, what's called an expression here, 3 divided by 4, is calculated first. That's then truncated, because it's integer divided by integer, truncated to a 0, and then essentially you're running round on a 0 here. So you can see, of course, that's going to result in a 0. So it's important to understand that order of operations, and I'll give you a few more examples of that. We can see kind of how it works just using some simple math. So if we type select 2 times 3 plus 1 and run this query, again ending with a semicolon, we're going to get 7. And you might think that makes sense. If I multiply 2 times 3 and add 1, I get 7. Well, what about this? 1 plus 2 times 3. All I did was move the 1 to the beginning of the expression. But do I get the same result? I do. So this is not evaluating this left to right. If you went left to right, 1 plus 2 is 3, 3 times 3 is 9. So the 2 times 3 is being evaluated first, and then the addition of the 1, regardless of the order. And that's the order of operations. So multiplication and division happens at the same time. And then addition and subtraction happens. Okay? Let me show you something. If we want to change the order of operations, it's very easy to do. So let's say we wanted to keep the order 2 times 3 plus 1. We wanted to specify it in that order, but we wanted the 3 plus 1 to happen first. We just have to put parentheses around it. And let's comment out this line above. I'll show you a little trick. If you highlight multiple lines, you can do one or you could do multiple, and then hit Control /, it automatically puts in the 2 dashes on each line you have highlighted and comments it out. So then when you run it, it's only going to run this one line. Let's see what happens. We get 8. So we've essentially forced the 3 plus 1 to happen first, which equals 4, and then 2 times 4 is 8. Whereas without the parentheses, it goes back to 7. The 2 times 3 happens first, and then the plus 1. Okay, the next thing I wanted to show you is that math is not just limited to literals. Again, I mentioned there are times that you want to use literals in doing queries that involve data from the table. So for instance, let's say we wanted to select, again select says what columns we want to show. We want age, but we want it to be multiplied times 2 for each person. We're going to pull from the users table, so from users, let's run that and see what we get. Notice we get each of the ages multiplied times 2, and we can look above to confirm that's what happened. 33 times 2 is 66. Null, which is unknown, times 2, well, unknown times 2, still going to be unknown, so null. 12 times 2 is 24, and 45 times 2 is 90. Okay, see you in the next lesson.